Hello there. In this video we're going to prove one of the logarithm rules, namely that the logarithm of m times n is equal to the logarithm of m plus the logarithm of n. So that's the goal for this video. And then once you have that one, you can actually apply it to all the other ones. It's kind of a building block. So one of the things that we need that we're going to use for this is we're going to use the fact that what is it? A is equal to 10 to the log A. And you can test this out in your calculator and such, do some little inductive reasoning there and see that that works, but that's something that's going to hold true. And we're going to use it. So we're going to actually start with the expression of m times n. So m times n. Well, certainly m times n, m has to equal 10 to the log m, and n has to equal 10 to the log n. So like this little thing here is whole m, this little thing here, that's n. Now we actually know from our exponent rules, these have the same base, so I could actually add their powers together. Log m plus log n. And if we had like 2 to the 10th times 2 to the 8th, we could add 10 and 8 and get 2 to the 18th. Okay, so we got that. Now in the next step, I'm going to take the logarithm of both of these things here. Log of that whole thing, log of this whole thing. So on the left, I get logarithm of m times n. But over here on the right, I now have logarithm of 10 to some power. Log of 10 to some power just reveals that power, and you get log m plus log n. And voila, there's our rule. And you can use this rule to establish basically all of the other rules too. So because of this, it actually has to be true that the logarithm of m to the n, well really that's logarithm of m times m times m n times. And when you're doing this m times, so you got m times m times m, that's really equal to log m plus log m plus log m n times, and that's just multiplication. So that whole thing there would equal n times the logarithm of m, which is what we saw in the rule, that you have that logarithm of some number to a power, that power comes out in front just like that. And you can also use this with inverse, with negative exponents to get the quotient rules. Alright, thanks for watching. Character and Scholarship for Life.